Happy Ice Cream Cone Company makes cake cones and sugar cones, both of which must be processed in the mixing department and the baking department. Manufacturing one batch of cake cones requires 1 hour in the mixing department and 2 hours in the baking department, and producing one batch of sugar cones requires 3 hours in the mixing department and 1 hour in the baking department. Each department is operated for at most 12 hours per day. Find the optimal strategy if profits are 180 per batch of cake cones and 120 per batch of sugar cones. So the first thing we want to do is decide what the variables are. And it looks like they're talking about two main things, cake cones and sugar cones. So let's just call cake cones X and sugar cones Y. So we are talking about profits. This means this would be a maximize problem. So we want to maximize P equal. And this one's a little bit different than the last couple that we've seen because it just comes right out and tells you the profits right here. So 180x plus 120y. So now let's go back and reread the problem and get the constraints. Subject to. Okay. So you look through and you see a lot of numbers, and there's 1 hour and 2 hours and 3 hours and 1 hour. Those aren't really our limitations. We need to look for numbers that are limits on the problem, and it says something about at most 12. Okay, so at most means less than or equal, but notice it says each department. Okay, so there's going to be two different things, and you look at the two departments. There's the mixing department and there's the baking department. So we're going to have two different inequalities, both of which say they're at most 12. There's mixing and there's baking. So go through and look at the numbers that are talking about mixing and the numbers that are talking about baking. So it says cake cones require 1 hour in the mixing department. Okay, so 1 hour in the mixing department. And then this 2 hours is in the baking department. So leave that alone. Let's just look for mixing for right now. So cake cones, that's 1x. And then later it says one batch of sugar cones requires 3 hours in the mixing department. So that's going to be 3y. Notice the x was for cake cones and the y was for sugar cones. So let's go back through, and now we talk about baking. This one says 2 hours baking for the cake cones and 1 hour baking for the sugar cones. So that's going to be 2x plus y right there. Now that's really all of the numbers. Don't forget this extra constraint. X is greater than or equals 0, y is greater than or equals 0. That just forces my cake cones and sugar cones to be positive. I'm not going to have a negative number of cones. So now let's graph. First constraint was x plus 3y is less than or equal 12. Next one, 2x plus y is less than or equal 12. X is greater than or equal 0. Y is greater than or equal 0. And there you have it. Again, I like them all to be the same color. I think it's just easier to see. So when they're all the same color, it's pretty easy for me to tell that I'm looking at this. This is the darkest region. This is the only spot that's been shaded all 4 times, once for each of the inequalities. So let's grab the corners here. Decimals. Okay. Okay, so this is what we have. And let's kind of do a little sketch here. Only need the first quadrant. Something like that. And we're basically looking at this region right here, this quadrilateral region. That is the feasible region, meaning that's where the solution has to be. But the optimal solution has to be at one of these corners. Okay, 0, 0, 6, 0, 0, 4, 4.8. Okay. Four 4.8, 2.4, is that right? Okay. All right, so find the optimal strategy. That's basically what should we do? How many batches of cookies there? I guess the optimal strategy and part B, when it says how much profit should the company expect, that's pretty much the same question, right? So we need to plug in those corners to find that maximized profit, or their strategy. Their strategy would be how many batches of each of the cones they should make. So we're going to do, let's see, I'm trying to find where I have room. 180 times 0 plus 120 times 0 is definitely going to equal 0. Okay. And 180 times 6 plus 120 times 0 equals 1080. 180 times 4.8 plus 120 times 2.4 is 1152. And 180 times 0 plus 120 times 4 is 480. Okay, so we're trying to maximize profit. You find that maximum number. The biggest number is this 1152 right here. Okay, so how much profit should the company expect? They should expect a profit of $1,152. All right, but the optimal strategy would be how many of each. Okay, so this is kind of a weird question because it looks like we'd have to make 4.8 batches of cake cones and 2.4 batches of sugar cones. So I'm not even sure if you're allowed to make 4.8 batches of something, but that looks like what the answer would be. All right, so your strategy, make 4.8 batches of cake cones and 2.4 batches of sugar cones. That's going to lead to your optimal profit, your maximum profit of 1,152. Part C, is it possible to make 3 batches of cake cones and 2 batches of sugar cones in one day? All right, so is that possible? Well, basically what they're doing is they're asking you if this point is in the feasible region. So let's look at Desmos again. Okay, and let's see if we can graph a point 3, 2. All right, so see how 3, 2 is inside this region? Feasible region, possible. Okay, so yes, that's possible. It's possible to do that. But then they also ask if it's possible to make 4 cake and 6 sugar. So 4 and 6. Let's check it out. Aha, check it out. 4, 6 is not inside the feasible region. Basically, that means it's not going to fit inside these inequalities. It doesn't work.